Hi, in this video we will present and explain in detail our IoT project named Smart Organ Delivery. For this project we developed a smart platform for organ delivery. The idea arose from the need to have a real-time information on the health status of the organ during the transport to the hospital where the transplant will take place. With this information, a vast improvement on the transport reliability and safety is then possible. The smart platform includes a box containing several simulated sensors on which various services are made available for data monitoring. We will now describe the structure of the hardware and all the services. Then we will analyze how they communicate and exchange information through the catalog. From sensors' point of view, all the scripts simulating the sensors have a similar structure and perform two main functions. Each sensor is initially registering itself to the catalog by providing the following information. The registration to the catalog is done by a put request. Then, all the sensors simulate the production of a physical data that will be saved in a SNML formatted JSON. The simulated data are then published under a specific topic and are made available to all services that would like to use them. From a services point of view, similar to sensors, all data analysis services have the same structure. However, they perform three different functions. Firstly, they register to the catalog by providing the following information. The registration is done by means of a put request. In order to receive data from the sensors, the services request all sensors publication topics from the catalog through a GET request. Once subscribed to the topics, they check the received data by applying a threshold. The result of the analysis is then published with a topic specifically associated with the target service. The main component that allows the communication among different actors in the network is the box catalog. The box catalog performs the function of a service catalog and a device catalog at the same time. By means of a put request, all sensors and services for data analysis are registered into two different separate lists. The catalog also receives put requests in order to update the configuration file and to keep track of the users subscribed to the web application. In addition to the registration of devices and services, the catalog has the task of providing information to various actors that are obtaining through a GET request. In particular, the catalog provides to the services the topics under which the data of all sensors are published. For example, in order to receive the publication topics of the temperature sensors, the temperature control service must make a GET request to the catalog, which will provide a list of specific topics to receive temperature information of all active boxes. In addition, the catalog provides to the health control service and to the Telegram bot a list of topics through which the active services publish their analytics, both to keep track of the data analysis and even to alert the users in real time if there are some parameters out of range. Secondly, the box catalog exchanges a JSON-based file containing user data with the web application. The box catalog is even used as a data exchange point between Node-RED and ThinkSpeak by providing specifically read access keys to the ThinkSpeak channels. Finally, it provides to the ThinkSpeak adapter a list of all active devices and services so that it can record data in the cloud storage. The data produced by the sensors and the result of the analysis are saved on ThinkSpeak, which is a cloud storage service provided by Mathwork. In this context, the ThinkSpeak adapter collects SNML formatted JSON files from sensors and services via MQTT and publishes them on ThinkSpeak every 30 seconds. Each sensors and the health status control services has a dedicated ThinkSpeak channel where data are collected. In particular, the ThinkSpeak adapter initially requests the topics with which the sensors and the services publish their data through a GET request. It then subscribes to this topic and receives all data that will be set and saved on ThinkSpeak channels. If a channel dedicated to a particular sensor or services does not yet exist, the new channel is automatically created using the Create New Channel method. Here we can see an example of a ThinkSpeak channel related to health status for box 1 and for box 2. Users, such as doctors and hospitals, can keep track of the data for each box using a specially developed web application. In addition, the surgical team waiting for the organ and the transport team can receive notification via the Telegram bot. From the web application point of view, at first it makes a GET request to the TeamSpeak where the public URL of the catalog is saved. This URL will be used to make a POST request to send the JSON file of the user access data to the box catalog. The user data is a JSON file that contains all the user information. Through a GET request, Node-RED will send the public URL of the dashboard in the URL parameters. The web application exposes a GET method to return desktop and mobile version of the website in according to the different type of users, hospitals, doctors, and so on. It exposes even a POST method to manage all HTML requests such as registration, login input, and all the action that can be performed by the different users. The web application also has a method to send an email to complete the user's registration. Here we can see the Node-RED interface developed to display data in the web application. It performs different functions. At first, it makes a GET request to TeamSpeak where the public URL of the box catalog is saved. This URL is used to make a GET request for the JSON file containing the various TeamSpeak channel ID link where sensor data are saved. The link of each channel is saved in a global variable of the flow. It also performs a GET request to the web application to retrieve the dashboard public URL. Every 30 seconds, the global variables saved are used to make a GET request to the TeamSpeak channel to receive the last value saved from sensors and services. From the Telegram bot point of view, at first it makes a GET request to the TeamSpeak to ask for the public URL of the box catalog. Communication between Telegram bot and the box catalog takes place in order to register the Telegram bot as service, request user data from the web application, and the request service and GPS topics. The Telegram bot provides 5 different commands. The start command allows to insert username and password. If both of them are correct, the user list will be updated. The user list keeps track of all users who are communicating with the bot. The change team commands allow to switch from transport to surgical team or vice versa. The alarm on and alarm off command allow to activate or deactivate the bot notification of a particular parameter selected through a buttons. Automatically it sends a message as MQTT publisher in order to turn off or turn on the speaker. The finish command will end the communication and the bot will delete the chatted information from the list. Now we are going to see a demonstration of how our IoT project works. Once the instance on Amazon Web Services has been started, the connection to the Windows server is established via a remote desktop connection. Next, the box catalog is started, which connects locally and then via ngrok. Finally, the TeamSpeak adapter and the web application are started, so that they also remain up and running. The web application can be reached using a dedicated URL. Node-RED and the Telegram bot are started on a Raspberry board. The public URL of the Node-RED is obtained using ngrok. Here we can see an example of a dashboard. Right now, we are going to simulate the operation of 2 different boxes for organ delivery, box 1 and box 2. The box catalog receives subscription from both boxes simultaneously. At the same time, TeamSpeak also starts saving data in the cloud. We can notice that the correspondence between the data produced by the boxes and the data saved on TeamSpeak. The data produced by the boxes can be viewed from the web application. Here we can see the different registration modes for the 3 different stakeholders. This is an example of a login for an hospital. In this context, the hospital can manage its boxes by associating a box to each user, add a box or remove the box from the system. To view the data of the boxes the hospital owns, it connects to Node-RED and can switch from one box data to another box data. Here we show an example of a login for the National Health System, which can search for information according to hospital or according to active boxes. This is the mobile version of the web application. Examples of a doctor's login and sign up are shown. The website design is optimized for the use on the smartphones. Here we can see the link for the Telegram bot. Here we can see the use of the Telegram bot by two different users that works in parallel, who are part of the transport team and the surgical team. The transport team receives notification about organs parameters. The surgical team receives notification when the organ is about to arrive. The two teams can be changed while using the Telegram bot. Here we can see an activation command for activate the acceleration sensor. Hope you enjoyed our project. Thank you for your attention.